Hey, it's Tim, Pickup Truck Plus SUV Talk. I'm talking with Joe Tolkaz, who is the Stellantis Propulsion System Chief Engineer. I'm glad he put that down in his little bio line because that is a title, good title. So, hi, Joe, welcome.
Thank you. Great to be here.
We're talking about something you may know a thing or three about, the new Ramcharger, the EREV, which is causing people a lot of questions. I did a video a couple days ago, and I asked the audience for all these comments. Like I saw a bunch of comments coming in, so I was happy to be able to interview you. And I'm going to give a big shout out to the Ram communications team that put this together so quickly. I did the interview video Monday. Here it is Wednesday, so that's really cool that we had this opportunity. And I can tell you there is a substantial amount of interest in this. Like I was kind of blown away by how many people viewed it and commented, but also some of the people that don't quite understand it. And I think I kind of do. Truck dude, I'm getting caught up on this stuff. I'm a little behind the eight ball on some of this EV stuff, but I'm doing my best. So I wanted to start with a really basic question. The difference between a plug-in hybrid vehicle, which we've had now, the Jeep 4xe has a system where you plug it in, you have this battery, you have a little tiny gas engine. And then we have the EREV, which is a little bit different, right?
Yeah. So the way to think about it, I think the plug-in is a more generic title. The EREV is a piece of that bigger piece. In terms of engineering terms, the PHEVs typically will drive at lighter loads all electrically. So you can think of it as, city driving, maybe some light highway driving, definitely not towing trailers or going up grades. An REV is designed to run electrically in all scenarios. So we're very proud of the fact that we can drive all electric, towing a 14,000 pound trailer for 39 miles. We think that's something that a customer can find some value on. Someone who is maybe a tradesman, works around town, maybe a fleet operator, if they only are going a couple miles to the job site, they can drive their trailer electrically, bring it back at night into the yard, plug in overnight, and their maintenance costs go way down, right? They're not putting fuel in the vehicle. You're not running the engine, so you're not doing oil changes and filter changes. We think, there's a really good use case for that type of operation.
Yeah, and I'm going to pull up a graphic here you guys put out on Monday, but this kind of set it home with me is I understand it as in an EREV situation is that the engine doesn't send power to the wheels. It sends power to the battery, and the battery drives the vehicle in a nuanced, simplistic viewpoint. Is that pretty close?
It's very close, with one caveat. The power from we call the gen set, so the combination engine and generator actually puts power on the high voltage bus, just like the battery puts power on a high voltage bus. And the drive modules, the EDMs, pull power from that high voltage bus. So we don't need to send power through the battery to the wheels. That would actually limit us because we'd be limited to the output of the battery, what the battery cells are capable. But by putting it on the bus, the EDMs can draw it as needed, and you don't have that limitation of the throughput through the battery.
Okay. So I was able to talk to my audience to get a host of questions. Like I actually typed it out. I had 2 pages of notes and stuff. And just so everybody knows and be very clear about this, we're still early games. Like I told you in the Money's video, we're not talking about price, trim levels. That stuff's still not decided. That is a marketing leadership decision. We're talking engineering in this case. So first, a lot of questions that first came up was the main question was why the V6. I talked about this Monday. It sounded like it was availability. You had it, and it fit the NVH standards, and it seemed like that was the right choice. But there's still some questions out there.
Yeah, that's a great question. We get that a lot. I like to use the Einstein quote, which is the best solution is the simplest one that works. And if I can be so bold, I'd like to add a Tolkaz corollary, which is the best solution is the simplest one that meets the requirements. And a big requirement was the power output. As you saw in the graphics we showed on Monday, the generator is capable of 202 kilowatts. The engine's capable of 202 kilowatts. So they're really well matched. We had other engines in our portfolio that did that. One that we get a question on is why not a turbocharged 4-cylinder? And we do have an engine in our portfolio that would do that, but it's more complicated. It potentially revs higher than the 6. It's not as fuel efficient, and it's more difficult to package a 4-cylinder than a 6-cylinder. So lots of reasons drove us to the 6. I personally really like that engine. I have 2 vehicles that I personally own with that engine in it. It's been great. I think our customers are going to like it. I think Doug Killian used this analogy when he was talking earlier on Monday. One of the games we play with leadership is we take them in the car and we make them guess when the engine comes on, because there's no tachometer in the vehicle. And a lot of times, like, it came on there. And I'm like, no, it's all electric. Well, it's electric now, right? Nope, the engine just came on. So it's that quiet, and we're very proud of it because the character of the vehicle is an electric vehicle. We want it to be that. It wasn't designed to be a plug-in. It was designed to be an electric vehicle, but without the electric vehicle limitations, right? The things that we're all aware of: range anxiety, ability to tow, some of those other things. We think, this is the right formula.
Nice. And the other question came up was, why not do a diesel like trains do? But I'm going to guess, and tell me if I'm wrong, I'm going to guess that you guys don't, since the EcoDiesel's discontinued, you don't have anything in portfolio to use.
Yeah, diesels were never really considered. For one, diesels typically, from an after treatment perspective, tend to be more expensive than gas engines. The other thing is that diesels' big advantages are they are very good at lighter loads from an efficiency perspective. And, we have a really big battery on this vehicle compared to plug-ins and hybrids. And we don't feel that we're going to need to run the engine at light loads. We're going to run the engine where it's most efficient, which is at heavier loads, lower speed type things. And, when I'm talking about it, people also ask about why not an Atkinson cycle, because that's very popular in a lot of hybrids. Similar reasoning. Atkinson with a late intake valve closing typically offers really good fuel efficiency at lighter loads. And again, we don't feel we're going to run the engine at lighter loads. We didn't feel we needed that complexity and added costs for what we wanted to do.
Other questions, from truck guys, right? Serviceability, life parts and stuff. We're always concerned about that kind of stuff. But it sounds like, hearing from you the other day and thinking about this, from a serviceability standpoint, it's actually better because the engine's not running as long as you would a non-EREV. You get longer oil changes, I should say, less changes, times changing the filters. So serviceability is still the same with the Pentastar. You didn't make any changes there to the engine, right?
Right.
Of all things, probably.
Yeah. So if you take, typical oil changes, and we have an oil life monitor, which is pretty awesome. It works really well. But let's just, as a data point, let's say 7,500 miles is kind of the average point when people are changing their oil and their filter. That's 7,500 engine miles. So if your use model is you're driving, I don't know, I'll make it up, 100 miles a week, you can obviously do the math and see that rather than, an oil change every 3 to 5 months, the oil change is going to be longer. And one of the things that also comes up when that is people are worried, well, if I don't run the engine, what happens? And we have algorithms in place to protect that as well. As you know, if you don't run engines, like if you have like a muscle car you're storing over the winter or whatever, there can get water can get in the oil, and that obviously dilutes the viscosity of the oil. We can detect that, and we will actually run the engine, force the engine operation to burn off that water in the oil to avoid that low viscosity condition. So we've used lessons learned from other programs. This is a lesson learned we picked up from the plugins where this was an issue on some of our early ones, and we adapted and brought that learning into this vehicle.
And then I think a lot of people are really just skeptical about battery life of EVs and things and stuff like that. And it seems like to me when I talk to other engineers, the electric motors are really durable and reliable. There's really no issues there. And it seems like batteries are pretty reliable these days as far as EV batteries. And the way you've packaged this battery, it doesn't look like you can get much damage from hitting rocks or getting water. Was that part of the idea behind developing it?
Yeah, exactly. We have a protective plate on the bottom called below, and we've designed this vehicle for off-roading. I think I mentioned when we talked about the electric drive module, there's a locking differential. We call it the e-locker. So we're expecting customers to drive this like trucks. This is going to be a tough truck. We don't want to baby it. It's not intended to be a toy. It's intended to be a work truck or a play truck or however you want to use it. The battery is a consideration, and we've taken a lot of due care on that. We have what we call power limits in the battery. We've worked with our suppliers on the cells. They told us what we can effectively operate at in terms of power limits based on the state of charge of the battery and the temperature. And we don't violate those. We actually offset those a little bit in our control system to add a different level of protection that we're committed to make this operational for 8 years, 100,000 miles, or whatever the warranties are going to be claiming there. We want this thing to be, like I said, a truck. People like to drive trucks forever and ever, and we want this truck to live up to that kind of reputation.
Yeah, I was actually flipping through a few photos, and I mean this undercarriage of the vehicle, right? So the batteries, this is a control module on top of it, and this thing from the bottom. So I see it looks like the emission or the exhaust. That's looks pretty hardy.
Yeah, the exhaust system runs, at least on my screen, to the right there, and then we have our dual charge module that sits on top of that. That's the big silver box there, and yeah, this was, with trucks, there's a lot of room. My colleagues who work on smaller vehicles always laugh when I talk to them about packaging issues, because they said you got the biggest vehicle in the fleet you're working with and you still have packaging issues. But, we're putting a lot of battery there. We also wanted a lot of range from a gasoline perspective. So right behind that battery is a 27-gallon tank. And between those two, we're targeting about 690 miles, which starts to approach diesel-like capability to go 700 miles. That, the idea that you can drive, we did some kind of funny math. We said, okay, if I'm based in Detroit area, where can you go with 700 miles? And you can go pretty far. You can get almost to the Rockies from Detroit on 700 miles. So the idea, I think a human probably breaks down and needs coffee or other kind of breaks before the car is going to need some servicing. So
yeah, I definitely would have to stop a few times, just to well, I drink a lot of water. Okay, so looking at other questions on our forum, on forum.pickuptrucktalk.com, I got a bunch of questions. I'm going to give those guys some priority over there because they joined the forum. So this was a question that came up, and a few other people asked this question, but the RPM of the Pentastar for highway cruising, towing, basically info how hard the engine will be working, and charge cycle info. So the theory here that I've heard other people say is, and the thought process is, if you run out of the battery, then you got to use the engine, which I'm not sure that's accurate with EREV, but you can correct me. And if you do that, then how high does the RPMs run in the Pentastar? How much are you really force the engine to work to tow that 14,000 pounds?
Yeah, that slide you had up there before was pretty helpful because it talks about the different modes, the charge depletion mode versus charge sustaining mode. Let's talk about the charge depletion mode first. Okay. That's the one where you run just out of the battery. The red arrows are coming out of the battery to the EDMs. And we expect to be able to tow 14,000 pounds quite easily on that. 65 to 75 miles an hour. We've done tests like that. I think I mentioned the 39 miles in that kind of format. And then when you get down to the charge sustaining level, Tim Kniskis kept calling it when the battery's dead. I was shuddering. I said, don't call it when the battery's dead. Call it when the battery is empty or depleted. I prefer that term because
right, yeah.
we think our batteries are going to live. We don't want them to die. And we know they're going to live. But anyways, in terms of power, it's all going to be dependent upon what the demand needs are of the vehicle. So let's say level grade, you're probably, take some fat math, maybe like 120 kilowatts. The generator can easily do that all day long. As you start going up in grades, we've talked about our Davis Dam tests, that we have a special mode where we ask the customer, if let's say he's towing, if he hits the tow haul button, he is able to pull power from both the battery and the generator to do up Davis Dam. If you're not familiar with the Davis Dam route between Las Vegas and Hoover Dam, it's about a 11-mile grade. It starts about 550 feet at sea level, and it goes up to about 3,500. The charge sustaining or the charge hold button allows us to provide extra state of charge of the battery, and we can comfortably do that at the 45 mile an hour min speed limit. So we've kind of anticipated all the more severe cases of the use mile that the people might have. I mean, we do trucks, right? At Ram, we do trucks. We've taken trucks all over the U.S. and potentially all over the world. We know where the tough spots are. Some of the hills out west, some of the ones, out of Death Valley in like Towns Pass. We know that's a tough one just because you're starting below sea level and it's crazy hot, and you're going up to about a barrel of about 82, which is about a mile high, and it's still fairly warm. So we know the tough spots. We've tested on these tough spots. We've done virtual analysis on these tough spots before we've tested. We're comfortable that this truck can excel in those areas.
So, and just for my thinking, does the Pentastar kicks on to charge the battery, or in the tow haul mode both run? So does the Pentastar's RPM range change as you're towing? Does it use more power?
Yeah, we try to do what is called a pedal follower. So if the driver is tipping in because he wants to go faster and pass people, or he anticipates a grade, the RPM will kind of react to the foot, so to speak. During a steady state, we're trying to minimize RPM disturbances or engine speed disturbances. We try very hard to make it intuitive to the driver. We don't want the engine speed to change without a driver input. So when you get a chance to drive those, these vehicles, I think you'll see it drives very much like a conventional truck. It's not like some of the hybrids out there where you see them trying to pick the most optimal point, and through no input to the driver, they'll suddenly pick a different engine speed point. We know that's not something a truck driver, a truck buyer would want to do. So we're trying not to do something like that. So it's very dependent upon load and also the driver requests. And also, if I can add, one of the things we try to do is we look for opportunity to charge. So if you're at a lighter load, but the battery is depleted a bit, we may elevate the engine speed and torque levels to produce more power so that we can charge the battery when it's efficient to do so.
Yeah, I kind of thought that maybe when the battery's low and you had nothing in there, that it seemed like perfect opportunity for the engine to run a little bit stronger and, charge the battery. Yeah. Okay.
Yeah, exactly.
So the other question was, if your battery that you love happens to die for whatever reason, can you still start the truck up?
Yeah, we have a mode we call power looping. There's also a 12-volt battery with the vehicle.
Oh, okay.
So we support 12-volt loads through a device called the APM. So as long as the battery closes what we call the contactors, that shouldn't be a problem. If there's a isolation fault in the battery, which is extremely rare, the contactors may not close. because we're trying to protect the driver from a high voltage risk. That would be the only case where you may not be able to start.
I think that's a real concern for a lot of EV people, where like if you run out of EV, you're dead inside the road, you can't move your vehicle. I think this takes away, again, another pain point for a potential issue. I think that's really, smart. The tires, there's always questions about EVs. They always run these low range kind of tires and things. Are you using like regular truck tires to get the range? Nothing special?
Yeah, we've done a lot of work on tires. It's I'm not the expert because I'm a propulsion guy, but I've listened closely and I'm learning a lot about tires, to be honest. There was a lot of interest on being able to support the weight, right? Because and the pressure, tires and the pressure are very important for not fuel economy, but for ride feel. And there was a lot of work done to balance ride feel versus rolling resistance because we want this truck to be efficient. And interestingly enough, we started out with a tire that just wasn't meeting our targets from a drivability perspective. So we looked at some other compounds out there, and a supplier came to us and said, hey, try this one. And we liked it from a drivability, and it actually helped us from a rolling resistance perspective. It was actually better in that perspective. So it's a win-win for us. So yeah, that was an interesting optimization. At times, as you indicate, sometimes you decide whether you're trading off efficiency for ride versus the ability to support cargo. I think we came up with a really winner solution on the tires side.
Nice. I'll be curious to check those out. I guess going back to towing, I have a whole list of towing. So I remember there was a lot of talk about this 35% rule or level of the battery when you're towing, that you don't want to dip below that. Can you expand on that? I don't remember exactly what was talked about.
Yeah, I think that was in reference to the Davis Dam maneuver. Just to be clear, if you're driving steady state, and I always use Nebraska because I remember taking a trip when I was a kid through Nebraska going to Yellowstone. It seemed like I could see the Tetons for days at a time, and it never seemed to get closer. so I always use Nebraska as my reference. But
I live in Nebraska. So it's funny. I live in Nebraska.
Oh, yeah. Okay.
It's funny you brought that up.
Okay. Well, yeah, it's a great state, and I love my time when I've gone through there. But if you're driving through there and you're driving 65, 75, you can run at the min level of the battery all day long as long as you have fuel in the tank. So we feel we get combined range of about 266 miles. At least that's our target. We have to still certify yet with the government. But that's a substantial amount of time that you can drive a 14,000 pound trailer at steady state at a pretty substantial speed. What you're referencing is when you start getting into a grade like Davis Dam, like Towns Pass and Death Valley. We use the tow haul feature that people will most likely use because they want to take advantage of the other features of tow haul to make towing a trailer easier on the driver, so to speak. And we'll bump the state of charge that we try to control to. So the customer typically will see at charge sustaining point 0 at the battery, it's a little higher, let's say mid-teens. We'll provide an offset target above that. And for sake of discussion, let's say that's 35%. We'll charge up to that 35%. The reason for that is the higher the state of charge, the higher the voltage in the battery. The more voltage means more power to the motors and more capability for the vehicle. So that's some of the physics behind it.
I happen to find other information. It's funny, on the forum and different places, we've been sharing details everybody else got from these presentations. Like I heard this number, you heard that number, so we kind of put things together. But I heard curb weight is 7,500 pounds. But I know that the frame has been expanded as well. Do you have any idea, like a GVWR numbers or anything? Do you have any of that stuff yet?
Yeah, so we're, I think we're north of 20 from the gross combined vehicle weight. So yeah, when you figure, I mean, you can do the math pretty easily when you're getting close to 8,000 pounds with 14,000 pound trailer. That's puts you in the ballpark of about 22K. So that's kind of what we're shooting for.
And I'm going to round this off with the last kind of put things together. Lots of questions. Lots of people are excited about this from not just a half-ton perspective, but a heavy-duty perspective. I remember when I bought a Ford F-50, I bought the Power Boost back in 21, and that ability to use power as like a mobile generator is great for half-ton customers, but it really gets heavy-duty guys excited. From an RV camping, boondocking situation to horse trailers and guys who do roping. Like around me, a lot of people do roping. They actually sleep in their trailers. They have a setup for that. It'd be nice to have, for their standpoint, have power there from the truck, not have to run generators and things. And I just think that there's a lot of interest in that. I know that Doug had said during the presentation that there was no fifth wheel or gooseneck hookup for you guys from factory for half ton. But you guys got to be thinking about heavy duty, right? Did that ever create in your mind?
Yeah, we love the concept, right? We think it has a lot of advantages. We think it's scalable. I can't talk about future product right now, but the architecture is designed to be scalable is something I think I can say. And we'll have to wait and see.
Yeah. Well, I think a lot of people have been waiting and seeing. I think there's a lot of deposits going down as of yesterday. It really created a lot of excitement because, like you said, it's like, and I've said it's in other videos too, but like your cost of maintenance is down, your fuel cost can be down depending on how you use the truck. And then when you want to use a truck for real truck things like towing and things like that, you have that option. You're not limited to trying to find a charging station for a battery electric vehicle, undoing your trailer. Like some of these charging stations don't have the option of pulling with a trailer. There's always these obstacles, but this seems like it's the perfect mix of good technologies working together.
Yeah, I love this truck. I said that in the discussion on Monday. Can't wait to have the production version in my driveway. I've been driving the development ones. It has a lot of capability. Even if you're not a hardcore truck guy with a big old trailer, if you're taking it tailgating to a football game, I can see people setting up their TVs and their crock pots and their refrigerators and, being the hit of the tailgate. So I like everything about it. I just can't say enough about how positive this truck is.
Yeah, it just seems like it's the no-brainer. It's a great solution. So, well, thanks for coming on today.
Sure, it was great fun talking with you. Hopefully, your audience will be interested, and we want to sell a bunch of them. So happy to talk about
it. Okay, there you go. There's my interview with Joe talking about the Ramcharger from an engineering standpoint. Again, there were some questions about pricing and trims and bed lengths and things. They're still working that stuff out. That's a different department, different area, different leadership. There was questions about some Uconnect things. Again, different person. So I just want to talk only engineering. I'll have more on this truck in the future. We're going to keep talking more about this because it's definitely got guys like me excited. And it really has people like you excited. I've never seen the amount of comments come back that have been so positive about this powertrain. And again, it comes down to free gas around town. EV charging at home is really cheap. Gas when you need it for a long distance trip and towing. And it seems like it's really efficient. So I'm really excited about this. It's one of the innovations coming out last probably 5 or 6 years. I've been really interested in learning more about it. And I will be learning more about it. And you can learn more about it too. There you go. Make sure you check our videos out over here, website down below as well. pickuptrucktalk.com. Again, lots of questions come from the forum. I gave those guys priorities because the forum's really cool. Come over and check us out. As always, thanks for watching. I will see you down the road.